So, hello my friends, welcome back to another masterclass with our main gap filler for masterclasses. It's me again. And on the last time we showed how we need to work with Git. There were many questions how to dive deeper into this topic. And so we have now Git part 2. And I tried to show you some hopefully new stuff on Git, how to handle stuff, and just what you can do. I'm not sure if I can fill 1 hour, so hopefully you have more questions and we can do a live part where I can just show you stuff you asked or explain some stuff a little bit deeper. So let's start with the masterclass. The first thing I wanted to show is the topic Git flow. It was on the required list. What is Git flow? Basically, Git flow is what we are at the moment already doing. So it looks like this. So you have a normal Git structure with branches, and the Git flow tells us, okay, just use a master branch for your release stuff and have a develop branch. It's the purple one here. Have a develop branch. I can use the mouse. Use the develop branch for your actual development. And after you say, okay, I want to release to a store or to a server or something like this, merge the stuff into your master branch. And the benefit of doing so is that you can never end in a dead ending if you're using Git flow this way, because you always let flow the stuff into the master and not in other directions. So the normal way is you do your development on the develop branch and put it back to master, and you don't do any changes on master. And even if you need to do a hotfix, for example, you put this into the master, but also put this into develop. So always the develop contains at least the stuff what is in master, but then can have additional stuff, but the master never has stuff inside which is not in develop. So this is the main part of Git flow. How you should work, and to leave develop clean, it's what we are already doing is using the feature branches here. So you don't pollute the develop branch with stuff which is not already ready for deployment. So you put it into the feature branches, do your pull request, and move it then to develop. And after this is finished, you move it back to the master. So this is the normal flow you should have. And in the ideal form of Git flow, they even the master is not does not contain the full commits of develop. They do squashing there. But to be honest, I'm not a big fan of squashing because you lose history, and it's, in my opinion, it's totally unnecessary, because you don't harm the master branch if you have the other commits in there. So my proposal is, let's just do like we do now, like developing and develop, and then merging to master every release, tagging the stuff like I showed you in the last masterclass on Jira, and I think then we have a clean state. The only thing we very rarely do is hot fixing, but I think this should also not a problem to just do a new branch, put the stuff into the master branch, and then also in the develop branch. So this is basically Git flow. I think we don't need to explain it further because we're already doing it. So this was the presentation part. Now we come to the live part. YouTube is silent. Okay, is this still so? Somebody in the Hangout, can you tell me if you hear me or if I'm silent?
I hear you.
Okay, so YouTube guys don't hear me. Miloš, is it working after refresh? Hope so. Okay, I just continue. I do it a little bit bigger here so you can read it. Okay, I'm hearable. So, now I need my cheat sheet. Okay, so the first thing I want to show you in the live part is how you can use Git hooks. Git hooks is a system that you can hook into your code or into steps which Git is doing and run simple shell scripts there. And I just want to show this to you, how this works and how you can implement this to do code checks or clean up your code or stuff like this. So the first thing is we need to create a new app. I just choose some random stuff here, and we need an application file, and we put some code in there. Just some basic stuff. So we now have an app with one source file, and the first thing I do now is I initialize a new Git repository. I add my code, I commit my stuff, and now I have a working Git repository with one commit in there. So if I go now to my Git folder, then I see there the hooks folder. So I go there, and now I see the different files. They are all have the extension sample, so that the Git knows, okay, don't execute this stuff. But they are really good to see, okay, what we can do. So the name of the commit hook tells us when is this run. So for example, I have here the pre-commit hook. This means before, when the user is running the commit command, like committing code, before Git finally starts this command, it runs this shell script and looks for the exit code. That's what's always happening. Git is always checking, okay, the shell script I'm running, what is the exit code? If the exit code is 0, then everything is fine and I can continue. And if the exit code is something else than 0, then okay, some error happened and I abort the stuff I wanted to do. So in this case, it will abort the commit. The same goes for the push, rebase, receive. Receive is on the server side. It's not on the client side. And yeah, you can always look into these sample files and they explain, okay, when is this run? And there's also a really good documentation on git -scm.org where you find the whole Git documentation. So for our example, we want to implement a pre-commit hook, which checks the code for code quality, like is the formatting for my programming language right, or do I have syntax errors in there, or yeah, kind of these stuff. And this prevents me to commit defective code or wrong formatted code. And this leads to a very clean repository because you don't have shitty commits which then need revert commits and yeah, stuff like this. So the first thing we do is we just have a look at the pre-commit hook and just look what we can do there. So I look in there, and you have here at the top a short explanation what happens there, when is this called, and what you need to do to enable this. So they tell us here, okay, just rename it to just pre-commit results .sample, and then this will run. And what happened now is the shell script is just running with the current in the current folder structure. So Git is running this in go back, is running this shell script in this folder, so our main Git folder. and now you can run any script or program you have on the shell can be executed there. So we are now creating just a new hook called pre-commit. We ignore the sample code, have a new file, and I already prepared something here. So what we are doing here, this is a really basic script you can also use for other stuff. In the first line, it just checks, okay, which files are changed to the in this commit. So if I add a new file, only this file will come into the list of files here. So then it reads the list of files, and then it goes to a loop for every file, and then you can do stuff in there. So it first checks, okay, is this file to be deleted? Like I remove a file, and in the commit, it will delete it from the repository. If not, continue. And so I have a little shell script on my computer where I can just give a file, and it checks if the code is clean or if there are some defectives. I will show this later to you. So, and if this happens, if the you see it here with the mark here, it shows, okay, if this script fails, then run the code inside of the if statement and tell us the file name and exit with 1. And this exit with 1 is the important one, because this tells Git, okay, my check failed, and Git will abort the commit in this moment. So we just save this. Wait. What happened here? Okay, this is strange. What happened here? Oops. My fault. So again, wait. Again, the shell script code. I insert the stuff. Oh, now it works. So, and now we do some change to our code. So I edit my app file again. And yeah, add some other code. The question by Sven was why we are exiting even on the first line of failing. You can the normal thing you need to do. I need to show the code again. The thing here is I wouldn't do this way always, because only checking the files you changed is not only always valuable, because if I change some class file and the class file itself is working, but because of the changes other files are failing, then it makes no sense to only check the file you changed. So normally I would say just check the whole app. If I changed something, I just wanted you to show that it's possible to check only the files which are changed. But yes, you're right, you should scan the whole folder and not only the files you have. And the most code checking tools are you just give a folder and they check the complete code, and after they are finished, they give the exit code a 0 or 1. And so you see, okay, these files are wrong and these are the problems, and it fails. So for our little example, I think it's okay to do this, but yeah, your mention is right, Sven. Okay, so now I have our changes to our code base, and we check the commit hook, and yeah, we just check if we are right. Yeah, we have some changes, so I add this file now. Do another commit. So, and now we see a problem. Git is warning us that the commit hook is ignored because it's not executable. And the important thing is he's doing the commit. So he was not preventing me because the executable was, the script was not executable. So he ignored it and just continued. And this is really important. Just check the messages. So if I continue now, my script will never run. So what I need to do now is to make the script executable. So I use the Linux or Unix command change mod with the +X to say, okay, make it executable. And now I go to hooks, pre-commit hook, and make it executable. So, and now we do the next change. And add this file again, commit. Boom. And now we have a problem. Okay, it tells me your code sucks and it failed. So you see there is no change or commit message there. So it prevented now the commit. And if I do a git status, you see, okay, it's modified. I could not add this. So now I need to think, okay, what happened here? My awesome code checker does not tell me what's the problem. It just says, okay, the code is shit. And now I need to figure out what to do. So I think what the app is lacking is some really awesome code and some awesome new stuff we need to do. So yeah, let's just try this one with Python. Let's see what happens. Some random message, and boom, it works. So what the code checker is doing here, it just checks if I'm using awesome method names, and so we did. And now it works. And now we have a working code checker on our code base, and then every change I do, he will check all my files and will run. And if it fails, it just prevents my commit. So the basic usage is, for example, to run a code linter over your code or a style checker, and just prevent you to commit your code when it's not clean. So if you use the wrong indentation or variable formatting or something like this, this can be checked by tools on every programming language. You have pre-configured tools you can use. Just add them to your shell script. Just add them that they run every time you commit, and then they prevent you to insert shitty code. I wouldn't say this is a general rule for Stanwood. I think this should be per programming language and per team. You should decide what you want to do, how do you want to do it, and yeah, this is only for helping you how you can handle yeah, problems like this. So I think that's all here. So the next question was, how do I repair a broken master? A broken master happens if you ignoring the. I come back here. If you're ignoring this rule, like you put maybe hotfixes only in the master branch, but not in the develop branch. And if you do so, and the hotfix changes stuff you also changed in some commit in your development branch, then you always get conflicts. And I just prepared some kind of a sample code where the conflicts are so heavy that we cannot really continue to fix this. So we wait, I need where we need to clean up this code a little bit so we can work again. So I hope this is the right one. Yeah. So I have here a sample project. I think it's from Schneehöhen. I copied the code and modified it a little bit so I can just show you what's happening here. So we have what's important for us is we have a master branch and the development branch. And now I'm at the situation that I want to deploy this app to live system. So I need to merge the develop branch into master. So what I do is I do a git merge. I'm in the master branch and I do a merge of the develop branch and develop. And yeah, let's see what happens. Okay, we are getting many conflicts. And now I have a problem. I can say, okay, let's just fix the conflicts, but I can tell you if you have so many conflicts already, then it's getting really hard to fix this problem. Yeah, it's the risk is just too high that you are doing merging errors, because we are talking here about really big files with many changes, and the whole file is then conflicting, and you need to figure out, okay, which side is the right one. I always think you can fix merge errors with 1 or 2 lines, but if you come to more than 20 or 30 lines, then it's getting really hard to see, okay, what is the actual right code I need to save and what I need to kick out. So thinking of our Git flow tells me, okay, I don't need to fix these errors, because mostly normally the master branch should be at least contain the development branch should at least contain the stuff of master branch. So the easiest way, and mostly what I do, is I just create a new master branch. I know it's a little bit hacky, but to prevent the work here to merge the stuff, it's easier to just rename the branch and redo it. So what I'm doing here in the normal case is the first thing is here I do a git merge abort. So I abort this whole merging, because right now if I run git status, you see I have this problematic state. So I do a git merge abort, and now I'm back clean. And what I'm doing now is I check out the develop branch. And now I can rename my master branch. So I do a git branch -m, call it master, and the new one is master old. And if I now git branch, you see, okay, I don't have a master anymore. And what I'm doing now is just I'm on develop, so I say, okay, just git branch master, check out master. Now I have a clean state. I have a working master again, and now what I now need to do is to do a git push force to override the master. So here comes in that only admins can do this at the moment, or you need to pick me if I need to remove our master branch protection, so you cannot do a force push otherwise. The best thing is you just ask me if you want to do this, but in a nutshell, this is what I'm doing all the time when I'm fixing your master branches on your projects. So it's nothing special, but you always need to think about, okay, what I'm doing here. And the good thing on Git is you cannot really break it, because if you look at the list, I now have the develop branch, the new master, and I have master old. So I didn't lost any code, and even if there were some hotfixes in there, they are not lost. So we now have a clean master state, and I can say, okay, maybe I just do a cherry pick on commits in the branch here, and put them into my master branch. But I have a clean base where I can start working. So Lukas is questioning if this solution is keeping track of tags we have in master. As I explained last time, tags are not pinned to a branch. Tags are always or kind of a branch, so they always pointing directly to a commit. So changing branches, deleting branches, renaming them does not affect the tag itself, because the tag always goes to the commit. And in your Git client or on GitHub, where you see the tag, and when they tell you, okay, this branch has this tag inside, it just goes through the list of commits of this branch and looks, okay, which tags are in there. So you don't have the problem that this changes anything on the text. So this was cleaning up the master. Next thing is detached commits. So normally when we work on Git, you see I'm on the master branch, and if I check out another branch, develop, you see, okay, I'm now on develop. So I'm always working on a branch. If I commit stuff, it goes into this branch what I checked out at the moment, and so I add new commits in line. So, but what happens if I say, okay, I go into the Git log? Git log is just a commit log we have. The newest one is in the top, and then I can go down in the history here. And now I say, okay, just let's pick this hash here and say git check out this hash. So what happens now is, okay, Git is warning me what happens here. And I see, okay, I'm in the detached state. This should be also some kind of visible in your source tree or other Git client. And what it means is that we are now at the state in Git of this commit. So I told you last time that Git is always working like this. The commits are just points in the timeline history, and the branches are only a list of commits which are inside of this branch. So these commits are all in a timeline. You can think of one line with these dots, and the branches are only separating them by telling, okay, the master branch has this commit, and this commit, and develop has also this stuff, and also these commits here. And on a detached state, I'm going back from this branch list and just go to the direct commit points. And this is what happened here. I'm now not on a branch. I'm just on a direct hash of a commit. So what we're seeing now is the I think this was this one. We are now at the state of the repository from December 12th last year on this time, 2017. So, and what we can do now is, maybe it's for debugging. You want to see, okay, what happened at this time in the code, or in which state was the code there. But you can also do, for example, we can edit stuff. So we just use here this file. We just add something here and save it. And do another commit. Now Git is warning us, okay, you did a new commit, and it's on a detached head. So we see here a new hash line. It's a detached commit. We changed something, so it works like every time, but we are still on this fake branch, still on the commit we checked out. And if I'm now going back to for example, the master branch, it is warning me, okay, you are now back in the ordered timeline of a branch, but you have commits which are not assigned to any branch, which means there is a commit on a line, but it's not assigned to any branch. So it's it's not visible at the moment, but Git is telling us this. And if this happens to you, so you jump back in time and you wanted to change some code there, and you committed stuff, and now you're in this situation, it's really easy. You can just say, okay, git branch. It tells you also here, git branch. Just any name. I just name it detached, and then you add the hash code of the commit there. And if you now check out this new branch, then you see that we have this code in there, and now you can work with this branch like a normal feature branch. So if this ever happens, it's really easy. Just create a new branch of this commit, and then you can do a pull request on this code and put it back into your stuff. So next thing is how do I prepare our repositories when we are open sourcing stuff? I'm doing a really harsh way to release our open source stuff, because I think it makes no sense to open source also our code history to all the developers. In my opinion, it makes sense to, if we say we release a new library in the first version, it's the 1.0, then there should be no history, and the history should begin at the moment we release this app. To keep our history, I always copy the repository I need to publish, and do some kind of an archive project of this in GitHub, so we don't lose the history. But I think it makes no sense to put the history to all developers in the world, because there's always a risk that at some point we added some passwords or certificates or stuff like this into our code. And yeah, there are tools to clean this up and remove the stuff, but to be honest, we could not always be sure that it's all clean. So I think the best thing is to say, go to your repository. That's what I'm doing normally. So I check out the master branch of the repository normally, or maybe the develop branch, to just have the latest code. And what I'm doing then is just remove the Git folder. So we remove all history. I have a clean state here. There's no Git folder at the moment. So next I init a new one and add just all files to this repository. So what's happening here? Okay. If you ever see this warning, this comes from Windows machines. So we have in this text file there is the line feed. So the new line command is on Windows machines is, I think, \n\r, and on Linux and Unix machines it's just \n. And Git is telling us that this is maybe a problem. And what he's saying here is, okay, I take this Windows line feeds, but I replace them with normal line feeds. So out of the \n\r, it makes only \n. So this is what he tells us here. This mostly happens in text files. It's sometimes, if you have Windows developers in your team, it could also happen in code files. But normally it should not affect you, because as it says, it converts them. And only the Windows guy, most Git configuration on Windows automatically do this. They check out maybe Unix files with a normal line feed, and they do the change back after you checked out to translate the line feed to carriage return line feed like the Windows guys needs. So this is not really a problem here. So I edit the files, I do my initial commit. He creates all the stuff, and if I do now git log, I only have one commit. And also I only have one branch. And if I'm done with this, I add a new origin, so the new name of my repository. I just choose some random name here, and then I can do a git push -u to track the origin branch, as I told you last time. And that's all. So now it pushes the whole repository to this repository to GitHub, and there are no history items or no risky stuff in there. Also no branches. It's only one branch. You see it is now ready, and we have now a clean repository without any history, and can be sure, okay, there is no stuff hiding in the background. Yeah, if you really want to open source also the history, we can do this, but yeah, for me, mostly it makes no sense. But we can always talk, of course. So the problem is now I'm out of topics because the feedback was not too high in the masterclass branch. But I have one goodie while we're waiting for more questions. I talked about visualizing Git, and I'm not sure if you guys know this, that you can visualize code changes. So yesterday I searched through our code base what is a good example for some stuff which is changing very often. So I figured out that the architecture framework of Android is really cool because it's relatively fresh, and we have many changes in a short time. And what I'm doing now is using a tool called GORS. It's this one. You tell the tool, okay, which resolution I want to have. The -0, I don't know. And I also don't know what this is. But what we are doing is repiping the content to FFmpeg, so making a video out of this. And if I run the command, you can ignore the other stuff here. If I run the command now, you don't see it, but I put it in there. And now you're seeing a history of what happened in the Git repository. You see that Sven is doing stuff here. He's beaming with a laser new code in there. And you see some kind of a tree structure, how this repository looks like. And if you rate, now you see, okay, many guys start to work here. Now it's Milos in there, Sven is doing stuff. And it's really awesome to see, okay, what's happening here. And you also see, okay, when there are big addings of new code or when there are big removals of code. You have here the time code. And in the background, FFmpeg is now saving this to a video file. So if you have run this one time, you have a video file which shows you, you can play on any device you want. Yeah, I also really like it. In some other kind of company, we display this on wall displays because it looks so awesome. And to bring a little bit fun in this, I wanted to show what happened on our IPS project. What happens if you add some huge framework like the SAP framework. So I just run the command again here. And I hope it's fast enough for you to see. So I need to explain short. In the beginning, Ronan got the code of the app of the client, which was already there, and then we did a huge refactoring. And one of the refactorings was also to change the SAP framework to a new version. And what you're seeing now is that the screen is exploding because so many source files in there. It looks a little bit like you do a normal Node.js installation. I think it's the same kind of explosion you will see. So I just run this. So you see Hannes is creating here a git ignore file. First time, mostly you see, okay, he's creating some kind of a README file. and now nothing happens. Now Ronin comes in and puts in the first files. Yeah, we see some files, and now you will see, okay, he will add now it explodes. This is the SAP framework. So this is, it's really good to see the dimension of corporate frameworks you integrate. I think every Node.js installation will look like this, and now you see this big tree of files we have, and we need to carry in this app also. So it's really funny to have, and maybe you should try it on your own code. It's really awesome. The best thing to do is to run it on the Linux kernel source code, because they have many commits, and many people working on this, so it looks like a Star Wars space fight when all the guys are putting in code there. So yeah, you can try this all the time you need. It's already rendered in HD, Richard. It's 70 20p, but you can choose any resolution you want. It was this year. You tell the tool which resolution you want. So you can also do 4K. Yeah, it's without frame loss because it's rendering frame by frame, and you have a clean video after this. So this was my masterclass at first. So we have questions here. Stefan is asking, are you using this workflow for every new version release as well? No, it's only for the open source frameworks. The repositories we are open sourcing, because I think if we open source stuff, there should be not our history in there, but it also makes no sense for the developer who uses the repository to see all the history, because if we release the 1.0 of our tracking framework or something like this, he only needs this version. He don't needs to see the history, but then we should keep the history of all changes which are coming later. So this is the thinking behind of this. So I will not say that I'm that's the only way, but I think it makes sense for me. But if you see it other way, we can change it, of course. So do we have any other questions? Do you have stuff you want to see? I can try now live. Just post it into our masterclass channel if you want. Interactive merges. Okay, Ronan, you need to explain this a little bit more, please. Okay, in the last masterclass, we already did the merging with conflicts. So what is the exact problem you want to see? Okay, I'm not quite sure what Ronan needs here. Yeah, I think the best way to fix conflicts is to use the merge tool of Git itself, or of your visual Git tool you use on your Mac, because it's the cleanest way. And I wouldn't do fixing merge conflicts on the shell, because it's mostly it's better to see, okay, left and right, what is the new code, what is the old code, to just compare the stuff and do a clean stuff there. But what I can show you, what goes in the same direction, is how to work with with a source tree on changes in the repository. So I just need to open it. Maybe we take the documentation framework, documentation repository. So this is our documentation repository we all had before our wiki comes up, and I'm not sure if I have changes here. Okay, I need to do some change. Okay, so the first thing is we go to our documentation repository and some changes here. So first line, and another thing is here's some changes. And let's do another one, or just delete the stuff here. So I did note some changes to the file, and if I now go back to source tree, it shows me my file changed. And what's really awesome here is you of course can always stage your file and do the commit, but you can also stage lines. So if you have the file unstaged here, you see the stuff which is changed on the other side. So what I can say now, okay, stage hunk, and what happens now, the README file is still in unstaged, but it's in staged, but only the line I changed here. So this comes very handy if you working on 3 tickets in a row and now need to do the commits for each of the tickets. Then you can go to source tree and just pick the stuff you want into one commit, line by line, and do the commit, and then do the next changes afterwards. So I can also say, okay, yeah. So yeah, this is what I need to tell. If Git sees, okay, there are many lines between the changes, it makes hunks of them. So I staged this one, and now you see, okay, here are not too many lines between them, so it's one change for source tree. And yeah, here's another one. And what you can do now is say, okay, no, I just want these lines here. So I mark them, then click stage lines, and they are also in there. And also I can say, okay, of this thing here, I only want these 2 lines removed, or 3 lines, and the other ones keep there. So in your code, you can really pick up or pick the stuff you want to change. And now you see my commit is in there. It looks like this. You see the result file. And now I can do the commit. And if I go back to commit, you see this file is still there, but only with the stuff I left. So this is really handy to do a clean commits you want to do. It's also possible to do this via the shell, but to be honest, I don't do this because it's better to do this visually, to just mark the lines you want to have in there, and yeah, to have a clean commit in there. So are there any other questions? You can also go to Hangout and talk directly to me if it's easier. Okay, I think we wait 1 minute, and still we got the 1 hour nearly. Yeah. While we are waiting, I hope I could show you some new stuff in there. And if there's stuff missing, just tell me, and yeah, I will try to show it to you. So
thank you, Martin. No, just to say thank you for another class, and I think there are no more questions at the moment, so we can leave it at that.
Okay, then thank you for your time and have a good day.
Bye.
Bye.